Welcome back. Previously, we reviewed solving systems of two linear equations using substitution and elimination. In this lesson, we're going to focus on solving systems of linear equations using elimination. Let's take a look at example 1. Our goal when we use elimination to solve a system is to have the coefficients be additive inverses of each other. So we want either the coefficients of the x's or the y's to be additive inverses. So we want to look for the least common multiple between the coefficients. The least common multiple between 6 and 9 is 18. So I'm going to multiply the first equation by -3. So its coefficient is a positive 18x. So we multiply the first equation by -3. We get 18x minus 27y equals 45. For the second equation, since I want it to be negative, I can just multiply the second equation by 2. So my new second equation is going to be negative 18x plus 8y equals 12. Now that the coefficients of the x terms are additive inverses of each other, I can add the two equations together. When I do, the x terms are eliminated because 18x plus negative 18x is 0x, or 0. Negative 27y plus 8y gives me negative 19y, and 45 plus 12 is 57. Divide both sides of the equation by negative 19 to solve for y, and we get y is equal to negative 3. Once we solve for one variable, we're going to substitute that variable into one of the equations to solve for the other variable. So I'm going to use the first equation. I'm going to substitute the negative 3 for y in order to solve for x. 9 times negative 3 is negative 27. I need to add 27 to both sides of the equation. Then divide both sides of the equation by negative 6. And we get x equals negative 2. So the solution to this system is the ordered pair, negative 2, negative 3. Our final step is to check. I'm going to check using the second equation by substituting in negative 2 for x and negative 3 for y. When we simplify, I get 18 minus 12, and 18 minus 12 is 6. So we know we solved the solution correctly since our check is correct. Let's look at another example. Again, our goal is to have the coefficients of one of the variables to be additive inverses of each other. So for this example, I'm going to look at the coefficients of y. And I have 2 and 9. The least common multiple between 2 and 9 is going to be 18. So for the first equation, I'm going to have to multiply the equation by 9. So we get negative 63x minus 18y equals 99. For the second equation, I need to multiply by 2. So we're going to get 10x plus 18y equals 60. Now that the coefficients of y's are additive inverses of each other, when we add the equation together, the y terms are eliminated. Divide both sides by negative 53, and we get x equals negative 3. Step 3. We need to substitute the negative 3 for x in the first equation to find y. Simplify. Negative 7 times negative 3 is 21. Subtract 21 from both sides of the equation. Divide both sides by negative 2, and we get a y value of 5. So the ordered pair solution for this equation is negative 3, 5. We're going to check using the second equation. So I'm going to substitute in negative 3 for x and 5 for y. And when we simplify, we get a true statement, so we know we solved and found the correct solution. In our third example, I'm going to multiply the first equation by a positive 8. And then I need to multiply the second equation by -3 so that the coefficients of our x terms are additive inverses of each other. When we add the equations together, we're eliminating the x terms so we can solve for y. Here we get y equals 0. Substitute 0 for y in the first equation to find x. We get an x value of 1. So we have the ordered pair solution of 1, 0. I'm going to check using the second equation. So I'm going to substitute 1 for x and 0 for y. And our check works, so we know we solved the system correctly. So please complete the one problem of the day that I left for you on Google Classroom. And then there's also an assignment for you on Delta Math.